talk now about tonight's speaker. I'm very excited about this talk because what are you laughing at? Oh, he's the brownie can. So, so tonight's speaker is Robert Reeves, who many of you know about. He's a well-known author, written for a lot of publications and written a number of well-received books. One of the experts on the moon. By the way, we have another expert on the moon in the audience, Robert Garfinkel. Raise your hand, Robert, so people know who you are. He's written, is it 3 volumes? I fire. Oh, please do. And I think we still don't have our copy autographed by Rob. Yeah, we keep. Yeah, we keep forgetting to bring ours. So, okay. So I'll make sure you interrupt me at the end. By the way, for those of you who watched my performance at the last meeting, I'll try not to interrupt the speaker as much this time. Okay. So Robert, what do you think that's funny? I like. Do I amuse you? Okay. Do you think I'm anyway? This is my Goodfellas imitation. Okay. Robert Reeves has been exploring the cosmos since 1958 and took his first lunar photograph in 1959. Robert, how old were you when you started in 58?
I was 12.
Yeah, that's about right. I think a lot of us know that feeling. And Robert began photographing and exploring the moon while in high school, and his moon photography entry in the 1965 Alamo Regional Science Fair won him a trip to the Johnson Space Flight Center, which, by the way, is a really cool place. I highly recommend it. Rebecca and I were just there this year for the first time. Wow, what a great place to go. Johnson Space Flight Center, Houston, Texas, is where they control the Apollo missions, for example, the Gemini missions. And it's in Houston, and I highly recommend it, and I highly recommend getting one of the more expensive tours, by the way. Anyway, so he got to go there during the 8-day flight of Gemini 5, and Robert, I remember that really well. My nickname in junior high school was Gemini because I'd always get mysteriously sick every time a Gemini mission would go up.
I know the feeling.
Yes, summer 65. But I learned so much more by watching the programs. And anyway, I'll talk more about orbital mechanics later on. And today, Robert uses a C11, Celestron 11 Edge HD, and a Skywatcher 180 millimeter Maksutov for his lunar photography from his personal observatory located in Central Texas. Robert, I think it's not very far from the McDonald Observatory, if I remember correctly. Is that correct?
No, that's the Texas Star Party. And my observatory is actually about 50 feet that away in my backyard on top of my garage.
Oh, okay. And he is well published. If his name sounds familiar to you, there's a reason, because he's been publishing articles about astrophotography in Astronomy magazine. He's published over 250 magazine articles and 250 newspaper columns about astronomy. His articles have appeared in Sky and Telescope, Astronomy, Deep Sky Journal, Amateur Astronomy, and the Astrograph. And in 1994, he published his first book, The Superpower Space Race, followed by The Conquest of Space. And in 2000, he published Wide-Field Astrophotography, followed by Introduction to Digital Astrophotography, ... I could go on. I mean, Robert, you wrote so many books, I can't list them all. But one of them is Exploring the Moon with Robert Reeves, which was released in August of 2023. And although he's an accomplished deep sky astrophotographer, his current passion is repopularizing the moon within the amateur community by explaining the origin of the moon, the evolution of its face, and introducing its geology to moon lovers everywhere. And Robert has perfected imaging techniques that allow the amateur astronomer using modest equipment to exceed the quality of Earth-based professional lunar photographs taken during the Apollo era. And I could go on and on, but one other thing I want to say is Robert has an asteroid named after him, and his wife is 26591, Robert Reeves. His wife's is 26592. So I believe they're the only husband and wife team that have sequentially numbered asteroids. And by the way, Robert, mine is 24626, so I'm not that far from you. Anyway, anyway, without further ado, tonight's speaker, Robert Reeves. Go ahead, Robert.
Well, thank you. I appreciate the opportunity to speak, and I've always wanted to visit the chateau. I was in the area for AIC quite a few times, but just never could mesh with getting over there to visit the place. But maybe someday. Um, Thank you for that introduction. Like I said, I've been an astronomer for 65 years, an author, as you mentioned, a lecturer. I speak to many astronomy clubs. Spoken as far away as the Chinese Academy of Sciences in Beijing. And I believe I was the first Westerner to address that body about the moon. Um, Currently, I have a Celestron 14 up in my observatory, but it is used as a deep sky camera with a hyperstar on it. I prefer the C11 and the smaller 7-inch Maksudov for the moon because the local seeing is more agreeable with the smaller instruments. So I also work for the Celestron Telescope Company. I should mention that. I used to do tech help for them. Now I'm part of the marketing team, and I was part of the team that was in Dallas for the solar eclipse. So if you saw the solar eclipse on the Weather Channel, you were seeing it through my telescope. We teamed up with the Weather Channel, and they were broadcasting their live feed through the telescope that we provided. So moving on to tonight, Postcards from the Moon. I choose that title because it's a program I do on Facebook nowadays where I post a different lunar picture I've taken every day and do a little write up about it, the relevance of the target, any personal significance, and so forth. So I hope you are able to see some of my work on Facebook. Now, getting down to tonight's program, in the past half century since the Apollo missions, much has been appeared in the media about how we got to the moon, the politics of why we went to the moon, and the personalities that engineered, directed, and flew the Apollo missions to the moon. But when you get down to the basics, in the past half century since humans last set foot on the moon, how much does the average person know about the moon? Well, the answer is surprisingly little. And it's making it my mission to try to correct that. I've been in love with the moon my entire life. My earliest memories of the moon were watching moonrise through my bedroom window when I was a child. Now, today, the space age explorations have not stripped the wonder and the mystery that I felt for the moon when I was young. Now, there's a name for people like me, and I'm going to assume that Bob Garfinkel there shares this moniker. And before you say it, it is not lunatic. The actual word for somebody who loves the moon is selenophile. And I hope that after you enjoy this program, you see the moon in a little bit different light, and you too will become a selenophile. Now, over the past 20 years, I spent a large amount of time chasing big telescopes across the southern United States in order to take high-resolution lunar photographs. The Celestron 14 in the background there is my telescope. However, the big 24-inch is not. That's up in Waco. But the irony of it is, I find I can take better images of the moon from my own observatory at home with 7 to 11-inch telescopes because the poor seeing in South Texas does not degrade the image in smaller telescopes as much as it does in a larger telescope. So, how good is modern lunar imaging with modest amateur telescopes? The image on the right is a plate from the famous Kuiper Lunar Atlas. It was the best professional astronomers could do from the Earth in the 1960s. The image on the left was taken from my backyard with the Celestron 11 telescope. I'll let you be the judge which is the better image. So I say that I have no special talent. I've just been doing it an awful long time, so I think I figured out a few things. And I am only passionately curious. I do not have a degree in astronomy. Experience is my degree. So, talking about the moon shows us a world that is rugged yet serene, a world that is harsh yet beautiful, alien yet appealing, tortured yet is calm, and strange yet friendly. So, I present the moon as my playground, and I invite you to come out and play with me. So, when I was young, the moon was a big deal. The moon was a dream. It was a goal and a destination, a place of mystery to be explored by brave heroes who dared to ride a pillar of fire and set foot on another world. But in the mid 1960s, there was a fundamental shift in amateur astronomy. We succeeded in going to the moon with Apollo, and the introduction of the 8-inch Schmidt screen gave amateur astronomers an affordable, portable, powerful telescope and opened up the deep sky to amateur astronomers. No longer did they need to lug around big Newtonian telescopes to dark sky sites. They had a powerful telescope that would easily fit in the trunk of their car, and it changed the style of amateur astronomy. And the moon kind of faded from our dreams. My goal in this presentation is twofold: to bring the moon back within our astronomical realm, to make it something not to be avoided because it interferes with the deep sky, and to get you not to just look at the moon, but to understand it. Today, many astronomers consider the moon boring, a place covered with bumps and holes, but the moon is not visually static. The moon is a geological wonderland that changes day by day, even hour by hour, as the shadows play across the face of the moon. There is much to see on the moon once you know what to look for. So I want you to go back with me to the moon and rediscover its wonders. So tonight we're going to look at the creation of the moon, the evolution of the moon's face, understand the various forms of lunar geology, and then explore some sentimental lunar favorites. So, starting off with a summary of our understanding of the physical moon, the moon is not the primordial object we thought it was before the space age. The moon is made of rocky material that has been melted and heavily modified by both exogenic and endogenic forces, which is a fancy way of saying it's got smacked by asteroids and comets, and there's been a lot of volcanism on the moon. Two conclusions were drawn about the moon prior to the space age. The moon underwent a huge asteroid and comet bombardment about 500 million years after it was formed. Volcanic activity began about 700 million years after the moon formed and was prevalent for about 1 billion years. After 50 years of intense research, we've determined the moon remains lifeless. In all the lunar samples that have been returned to Earth, no living organisms, fossils, or organic compounds have been found. The lunar evolution process through the accretion of smaller bodies, melting, and impacts have left the moon with a crust about 60 kilometers deep and a uniform lithosphere reaching a depth of about 1,000 kilometers. Below it lies a partially liquid core, we think, and we still do not know for sure if the moon possesses a small iron core. The oldest rocks on the moon are the 4.6 billion year old light-colored highlands known as the terrae. The youngest rocks on the moon are the 3.2 billion year old mare formed by volcanic eruptions. Thus, the youngest rocks on the moon are as old as the oldest rocks on the Earth. Earth and moon formed from the same source material. The Earth and moon evolved similarly, but the moon is depleted in iron and volatile elements. Lunar rocks formed in high temperature events with little chemical reaction with water. Evidence of the earliest events that formed both the Earth and the moon are now only seen on the moon. So, lunar rocks can be broadly categorized into three types: volcanic basalts that erupted from the interior and formed the maria, anorthosites that are lightweight material that floated to the surface of an early molten moon, and breccias created by the mixing of other rocks crushed by meteorite impacts. So, after the moon solidified, it was blasted by thousands of asteroid impacts during the late heavy bombardment. The largest impacts created the basins that later flooded with lava to form the maria. The primordial moon was also much closer to the Earth than the modern moon. After it formed, the moon was perhaps no further away than today's geosynchronous satellites. So the crust on the far side of the moon is thicker than the near side. Most volcanic flooding in the basins occurred on the thinner crust near side. The higher density basalt within the near side basins displaced the moon's center of gravity, allowing the moon to enter a synchronous rotation and keep the same side facing Earth. So, over its billions of years of existence, the moon has been blasted by countless meteorite impacts that have crushed the upper layer of the crust into a mixture of dust and rock fragments called regolith. Because the impacts excavate rock samples from deep within the moon's crust, it is possible to gather samples to analyze the interior of the moon. Now, the earliest event on the moon was necessarily the creation of the moon. There are many theories about the creation of the moon, but the one that stood the best test of time, although it is still challenged and debated, is the giant impact model. In this case, the early proto-Earth was vying for supremacy with another Mars-sized body in a similar orbit, and about 4.6 billion years ago, the proto-Earth and this other body that we now hypothetically call Theia, collided. And in the collision, Earth was shattered, the proto-Earth was shattered, Theia was shattered, and the Earth-Moon system we know today coalesced from the shattered remains of this collision. Now, an early moon was molten. This science fiction like scene of a glowing sphere of rock flying through space may play well in pulp science fiction, but in reality, the early molten moon was probably a very dark body. A chilled skin of solidified rock formed on the surface and insulated the inside of it. Iron and heavy radioactive elements sank to the center. Silicates floated to the top in a global magma ocean, and it took millions of years for the moon to solidify. Now, over the course of time, the moon has undergone a period of geologic time epochs. Now, back when we were kids and we were fascinated with dinosaurs, we all remember the terms like the Jurassic era, the Triassic era, the Cretaceous era. Well, the moon underwent similar time periods in its geologic formation. Anything from about 3.92 billion years and earlier is pre-Nectarian, from the formation of the moon up to about 3.92 billion years ago. And then for a period of about 100 million years, the Nectarian epoch occurred. This coincided with the late heavy bombardment, where the Earth and all of the inner planets were heavily bombarded by asteroids and comets. That was followed by the Imbrian epoch, which lasted up until just under 3 billion years ago. During this period, extensive volcanic eruptions created the Maria that formed the face of the man in the moon. That was followed by about a 2 billion year period, the Aristotelian epoch, where most of the post-Mare cratering occurred, and that is followed by the Copernican epoch from about 1 billion years ago to the present. And any crater formed on the moon during this time can be identified by it typically still has a ray system. Crater rays are slowly erased by space weathering, and they fade after about 1 billion years. So if you see a crater that has a ray system, you can usually make bet that it is 1 billion years or younger. Now, looking at the ancient moon during the Nectarian epoch, this is about 3.85 to 3.92 billion years ago, the moon's crust had solidified, but the crater formation rate was 300 or more times the current impact rate. This is when the basins formed on the moon, the giant, enormous craters that eventually filled in with basalt to form the modern Maria. But during the Nectarian epoch, there was not yet any Maria-forming volcanism. That didn't occur until the the Imbrian epoch, between about 3.85 and 3.1 billion years ago. During this time, extensive volcanism filled in the low-lying basins, and the basins were obscured by the Maria formation. The modern epoch, the Copernican epoch, about 1 billion years ago to the present. As I said, we identify Copernican epoch craters by the presence of ray structure around them. And there is a significant reduction in the rate of crater formation. And that's a good thing, because if that impact rate had continued like in the early solar system, we would not be here debating this. So there are two primary landscape making processes on the moon. Everything we see on the moon was either the result of an impact or subsequent volcanic modification. So the most obvious things that we see with the volcanic activity are the Maria, the dark lunar seas. Back at the dawn of telescopic observation, these were assumed to be watery oceans, just like on Earth. But that idea went by the wayside pretty quickly when improved telescopes were returned to the moon. And the basins, we have to understand that the basins and the Maria laying within them are not the same feature. The basins were created by an asteroid impact. The Maria were formed by lava eruptions flooding the basins with basalt. And not all basins contain a Maria. There's almost 80 gravitationally or visually detected basins on both the near and far side of the moon. But the far side of the moon has no large Maria like the near side. The far side crust is thicker, restricted volcanic eruptions. So the face or the Maria define the face of the moon and create the caricature of the man in the moon. There are 21 named Maria on the near side. 11 were named by Giovanni Riccioli in the 17th century, and 8 were named in the 19th and 20th centuries. 2 were named during the space age. One of them so recent that I bought the house I'm living in now before that last Maria was named. That's Maria Insularum, the Sea of Islands between Kepler and Copernicus crater, named in 1976. Now, a key feature of the lunar Maria, here we see Maria Nectaris, Maria Crisium, Serenitatis. You see a common feature is they are round. The basalt fields are nested in a gigantic crater. In the case of Mare Imbrium, almost 1,000 kilometers across. So some significant craters on the face of the moon, but all paved over with Mare basalt. Mare Humorum, same thing, round. One Mare that is not round, Oceanus Procellarum, the only one that Giovanni Riccioli named as an ocean instead of a sea. Procellarum is double the size of Mare Imbrium, Imbrium being the man in the moon's left eye, and apparently to visually, telescopically, the largest Mare on the moon. But Procellarum, almost twice as big, but it is so foreshortened on the western limb of the moon that it barely contributes to the caricature of the face of the man on the moon. And not all of the basins completely filled up with basalt. Mare Austral, down in the southeast corner of the moon, is a collection of basalt-filled craters. Why didn't it fill with basalt like the near side basins? Well, its proximity to the far side. The far side has a thicker crust for various reasons that are still debated. I have my particular theory, but the far side crust is about 10 kilometers thicker than the near side, and that thicker crust restricted volcanic eruptions on the far side. So, and near the limb of the moon, the eruptions were slower and more prolonged. Thus, Mare Austral, which partially wraps around to the far side of the moon, is merely a collection of basalt-filled craters instead of one homogeneous, smooth lunar sea. And others, like Mare Frigoris, don't necessarily lie in a single basin. Frigoris stretches about 1,800 kilometers across the face of the moon. It kind of forms the eyebrows above the eyes of the man in the moon. And portions of this Maria may lie in the Procellarum, Imbrium, and Serenitatis basins. Now, lunar mountains are fundamentally different on the moon than they are here on Earth. Earth's mountains are continuously created by plate tectonics and volcanism and are eroded by Earth's weather oceans being subducted into the molten mantle of the Earth by plate tectonics. Lunar mountains were created by a different process, impacts. Lunar mountain chains are the raised rims of impact basins. Now there's some individual peaks that form at the center of crater impacts, but these are not mountain ranges. Lunar mountain ranges are the raised rim of an impact basin. And these lunar mountains have remained unchanged since their formation almost 4 billion years ago, whereas an earthly mountain can be significantly altered in as little as 100 million years. Oops. Now, one of the most popular telescopic mountain ranges, the Alps of northern Mare Imbrium, easily identified because it's right next to that very strange dark-floored plateau crater. Continuing around the eastern rim of the Imbrium Basin, we encounter the Caucasus Mountains and the Apennine Mountains stretching on down past Eratosthenes crater. And you notice the mountain ranges have familiar names. All lunar mountain ranges are named after terrestrial mountain ranges, such as the Carpathian Mountains just north of Copernicus crater. Now, not all lunar mountain ranges can be easily seen. Of course, we rely on the phase of the moon illuminating a particular mountain range, but the Cordillera Mountains, which are the outer impact ring surrounding the Oriental Basin on the western limb of the moon, can only be seen for 1 day a month. Up to about 13 days into the lunation, this region of the moon is in shadow. Then on the 13th day, as we see the if my cursor is visible, we see the shadow line created by the sunrise just past the Cordillera Mountains. And then further in, the Rook Mountains also cast a shadow. Those are the second of the impact rings around Oriental. And then finally, the inner impact ring around Mare Oriental itself. It officially has no name, but we call it the Inner Rook Mountains. Now, the trick is 12 days before, 12 days into the lunation, this is still in shadow. 13th day, yeah, we've got shadows peeking past these mountain ridges. We can see them. The 14th day, full moon. Now the moon is flatly, fully illuminated, and the shadows disappear. And for the rest of the lunar phase, the shadows are absent, and we no longer see the Cordillera and the Rooks against the jumble of other terrain. So these are rather remarkable in that they're only visible for 1 day a month. Now, some prominent mountain chains on the moon, such as the Western Crisium Impact Basin Ring, cradling Mare Imbrium, remain unnamed. There's quite a few features on the moon that are unnamed. Now, branching out into the types of craters on the moon, they're not all just cookie cutter holes in the ground. We can break craters up into various categories. There's a crater main sequence, borrowing a term from the stellar main sequence where we classify stars. If a crater is less than about 16 to 21 kilometers in diameter, the dynamics of the impact that created will simply carve out a bowl-shaped excavation on the moon. But if it is larger than 16 to 21 kilometers, the subsurface rock rebounds from the shock of the impact and rebounds up and creates a central peak. And the crater walls are so large that they're not structurally able to support themselves, and they collapse and tumble into the crater and form a series of terraced benches. And then, of course, if a crater is larger than 300 kilometers, we classify it as a basin. But that 300 kilometers is now not a hard, fast rule, because we are realizing that quite a number of smaller features like Grimaldi or Deslandres or okay, It just vanished out of my head. It's 10 o'clock here, way past my bedtime, and I've had a long, hard day working out in 100-degree heat. So a name is going to vanish from my mind every now and then. But we are finding that some of these smaller features are basins in their own right. So this 300-kilometer rule is not necessarily hard fast. So looking at some of the examples, simple crater, Helicon and Novariae up on northeastern Mariimbrium, a complex crater, Copernicus, prime example. We see the central peak in the middle, the collapsed terraced walls tumbling down into the interior. An example of a basin that did not fill with basalt on the near side, Bailey, down in the southwestern quadrant of the moon. Now, examples of complex craters, they all feature a central peak. And like I said, the terraced collapsed walls, Pythagoras up in the northwestern quadrant, Moretus down near the South Pole, Geminus up on the northeast. Now, crater rays are composed of pulverized glassy material thrown from the crater by the impact explosion that created the crater. As I mentioned earlier, crater rays fade after about 1 billion years, and they're an indication of the parent crater is young. And rays are brightest near the full moon. That's because crater ray material, it reflects light very similar to how the material in a interstate highway sign reflects your car headlights back to you, and you can read the writing on the sign before your headlights even illuminate the sign itself. You just see these letters glowing in the distance. Well, that material is very efficient at reflecting the light directly back at its source. In this case, your headlights. On the moon, when the Earth and the moon are aligned, when the moon is, when the Earth is between the moon and the sun at full moon, the ray material reflecting the light back toward the sun, and Earth is in line. Therefore, at full moon, the rays are brightest. Let me grab a drink. My voice is starting to go. Now, there's different kinds of rays. Monodirectional rays, such as those extending from Messier and Messier A, and the butterfly pattern, like the one extending from Proclus crater, are an indication of oblique impact. In this case, no ray material splashes back in the direction the impactor arrived from. Now, these impacts very oblique, perhaps 5 degrees or less above the horizon. Higher elevation impacts will create a full snowflake, fan-shaped spread of rays, but these extremely low, shallow, oblique impacts create the butterfly rays. Now, secondary craters are created by the impact of ejecta thrown by the crater's explosive formation. Secondary craters are shallow because the impact speed of the impactor cannot exceed the 2.4 kilometer per second escape velocity of the moon. If something is blasted out of the primary crater faster than that, it escapes and goes into orbit around the sun. Secondary craters often lay in linear chains, as we see radiating outward from Copernicus. And it's thought that a majority of smaller craters, or craters smaller than 20 kilometers, are secondary craters, but secondaries can appear hundreds of kilometers from a primary impact. So it's tough to associate a particular secondary with a primary impact. And not all craters are round. We've got elongated craters. Haensel is actually 2 merged round craters, and foreshortened down in the lower left-hand side of the moon to our earthly view. So our slanted perspective makes it look peanut-shaped. Ray to E down in the southeast corner, overlapping multiple impacts, again, created this keyhole-shaped crater. But Schiller is a single oblique impact. Schiller is a monster. I forget the exact figure, something like 170 kilometers long. 3 times longer than it is wide. But if Schiller's length were translated into a circular crater diameter, Schiller would be among the 10 largest craters on the moon. So whatever created it, it was a monstrous impact, very shallow, glancing impact. And other odd-shaped craters, Anaximander, up at the upper left, the merging of Anaximander A and B, pivoting on Carpenter crater creates the Valentine heart shape. Down on the lower left, the 4 components of the merged craters that form the crater collectively known as Meton. Looks kind of like a 4-leaf clover. Agrippa and Godin, very distinctly bullet-shaped and bell-shaped. So we have all kinds of crater shapes on the moon. There's even a square crater, which I'll point out. Now, floor fractured craters are another animal. These started out as the classic complex crater, central peak, collapsed terraced walls, but the craters, the impact that created the crater shattered the crust underneath the impact site and tapped down to reach into subterranean magma chambers. Volcanic eruptions pushed up through these crevices and elevated the floor of the crater, pushed it up, sometimes flooding it with basalt, and invariably leaving it with this series of rills within the crater, thus the term floor fractured crater. Gassendi up on northern Mare Humorum, a prime example. Posidonius up on the northeastern Mare Serenitatis. Atlas crater further north from Posidonius. Now, ghost craters are a classification of craters that existed before the Mare lava flooding. Many craters formed on the basin floor that were subsequently flooded with basalt to form the Maria. Now, some of the craters are they're gone, completely buried. We'll never see them anymore. But others are large enough that they either create ripples in the Mare basalt ridges, such as Lamont, just north of the Apollo 11 landing site, or the crater itself, its rim was high enough that it just breaches the surface, and we can see it as a ghostly ring. Stadius near Copernicus, an example. Flamsteed P, also known as the Flamsteed Ring, down on southern Procellarum. Crater chains, technically known by the term of catena, one of the Latin terms that was applied to the moon back in the 1970s. Some people either love it or hate it. I personally think the Latin throws a little bit of class into things, but crater chains created by the sequential impact of an object that broke up because of the Earth-Moon gravity system. Best example of that is, remember back Shoemaker-Levy 9, back in the 1990s, broke up in Jupiter's gravity and sequentially impacted Jupiter. Well, on the moon, this happened a little more quickly. Shoemaker-Levy 9 took about a week to finally bombard Jupiter, but here we see just above Ptolemaeus crater, Catena-Muller. On the western side of Ptolemaeus, Catena-Davy. Just south of the Apollo 16 landing site, Catena-Abulfado, the longest crater chain on the moon, stretching almost 200 kilometers. Another feature on the moon created by volcanism are wrinkle ridges. These are known by the scientific name of dorsum or dorsa, and are folds on the Mare surface where sheets of basalt have crushed together and buckled into a lengthy ridge that rarely exceeds several hundred meters in elevation, but they can extend for several hundred kilometers. Wrinkle ridges are usually named after Earth scientists, if they're named at all, and the most popular wrinkle ridge is known as the Serpentine Ridge on eastern Mare Serenitatis, as we see in this illustration, where the ropey strands of it twist together, and the Serpentine is the combined lengths of Dorsa Smirnov in the north and Dorsa Lister on the south. Uh, other wrinkle ridges, like on western Mare Imbrium, Dorsum Heim, um, far south of Sinus Iridum, but other unnamed wrinkle ridges look like frozen ocean waves washing into the horseshoe bay of Sinus Iridum. Rills on the moon, scientifically known as rima or rimae in the plural, are grooves or channels on the moon that are appreciably longer than they are wide. And rills are formed by three different processes. Oops, let's go the right way. Straight rills are formed by the slumping of land between parallel faults. In this case, the crust is split apart by a volcanic dike, or a sheet of magma that pushed up from the moon's molten core but did not breach its surface as a volcanic eruption. Examples, Ramahiciotis, down south of Mare Nubium, or on the southeastern shore of Oceanus Procellarum, we see Ramus Ursalis, extends almost 400 kilometers. Now, arcuate or curved rills are caused by the stretching of land near the edge of a maria. This happens when the mass of the Maria basalt slumps toward the middle of the basin and it pulls at the shoreline and pulls open these rills. So in this case, the triple rill system of Rima Hippalus looks very much like a giant cat scratch arcing around eastern Mare Humorum. Sinuous rills are formed by flowing streams of lava, much like channels are cut in the earth by flowing water. Flowing molten lava also carve channels on the moon. In this case, Rima Hadley, just between Palus Putridinus and the Apennine Mountains, is also the Apollo 15 landing site. Dave Scott and Jim Irwin explored this region back in 1971. Now, scarps on the moon are known scientifically as rupes, and they are formed by two different processes. Some scarps are the surviving rim of an impact basin. And in this illustration, Rupus altai is the outer surviving section of the outer impact ring around Mare Nectaris. The rest of it has been obliterated by subsequent impacts, but in this case, it is quite well preserved as the Altai scarp. And other scarps are created by the slumping of land on one side of a fault, such as the lower of these two parallel features, Rupus Cauchy. The one above it, Rima Cauchy, is a rill where the land has collapsed between two parallel faults, whereas Rupus Cauchy, the land has slumped on one side of a single fault. Now, the most famous cliff or Rupus on the moon, the straight wall, Rupus recta. It's one of the most beloved non-crater features on the moon, and we'll examine it a little bit more later. Past volcanic activity on the moon is evident in the form of pyroclastic deposits, sinuous rills, ash deposits around cinder cones, and volcanic domes. Here we see the Aristarchus Plateau, if I go the right direction, and the giant sinuous rill of Schroeder's Valley running through it, where billions of years ago, massive amounts of molten lava flowed down this rill and emptied out onto Oceanus Procellarum. This heart-shaped pyroclastic region, very close to the very center of the moon. It has no name, but its basic heart shape lends me to call it the heart of the moon. And notice it's noticeably darker than the surrounding territory. The volcanic vents in the Rima Hyginus to the south of it at one time erupted fire fountains of ash that darkened this particular region and gave it a darker shade. Other ash deposits around cinder cones in Alphonsus crater. You can see these in a telescope easily. 9 o'clock, 3 o'clock, 5:30 position around Aristarchus crater, Alphonsus crater. You can see these dark deposits. volcanic domes on the moon. The most famous ones, of course, are the Marias Hills, about 250 volcanic cones and domes just west of Marias Crater on Oceanus Procellarum. Further north on Procellarum, Mons Rumker rises about 1 kilometer and hosts about a half a dozen volcanic domes on top of it. Now, getting toward the end, close to the end of this, we'll look at a few features that become sentimental lunar favorites with people, whether you're an experienced observer or a novice. Things like Plato crater are going to get your attention. Plato is obviously very different. It is black, filled in with, it's paved over, flatter in a parking lot. It does not look like a crater, but at one time it was very similar in form to Tycho crater today. But volcanic flooding from below forced lavas up into the crater from below, paved over its interior to where now the lava fields within Plato are about 600 meters higher than the basalt fields of Mare Imbrium to the south. Well, let's keep going here. Mare Imbrium, as I was saying, Mare Frigoris up to the north. I was going to mention a square crater to you. There it is, W Bond, on the northern shore of Mare Frigoris. Its walls look like the ramparts of an ancient fort. And closer to Plato, now we're beginning to see detail in Plato. The 4 little craterlets within it. Plato's nested in the Alps mountains, which also feature the Alpine Valley. Another volcanically created feature, a graben, caused by the slumping of land between parallel faults. Little Mons Pico to the south and Mons Piton, these become very beloved observing targets as well. Little small mountains isolated on northern Imbrium, but people love them for some reason. Now, if I can keep my voice going for about another 5 minutes, we got a whip. Now, look at this little crater just south of Python. I'm sure you all have heard of the Norse god Thor and the trials and tribulations of Agent Coulson trying to find Mjolnir, Thor's hammer. Well, it's been laying there on the moon in plain sight all along. And closer yet to Plato. Moving on, Tycho crater, another beloved feature because of its fantastic hemisphere-wide ray system, the youngest large crater on the moon. We think it's only about 107, 108 million years old. The dinosaurs, Tyrannosaurus was roaming the Earth when Tycho formed, and the flash of the creation of Tycho on the moon startled many a dinosaur on Earth. Now, Plato lies among some of the oldest craters on the moon. Like I said, Tycho, a little over 100 million years old, but Longomontanus and Clavius, almost 40 times older, dating back to the Nectarian and pre-Nectarian epoch, shortly after the formation of the moon. Now, look closely at this picture. Sunrise is showing us some details we don't normally see. The surface near and around Tycho almost looks like it's rust pitted with thousands of tiny pits. These are secondary craters created by the massive amount of material blasted out of Tycho by the explosion that created the crater. Rain back down on the surface, and this low sunrise elevation scene, we can see thousands and thousands of secondary craters. And the same with this view. Copernicus crater, the early telescopic observation back in the 1600s, astronomers called Copernicus the monarch of the moon because of its huge snowflake-like ray pattern. But Copernicus is also magnificent at a sunrise or sunset. It lies just south of Mare Imbrium. Eratosthenes crater up to the northeast, the Apennine Mountains up above it. I always say that if there's any reason why the Apennine Mountains were put on the face of the moon, it was to point like a finger at Copernicus crater. And the Carpathian Mountains just north of Copernicus, the secondary craters that we had talked about earlier, and Mare Insularum, the Sea of Islands. I'd mentioned that lunar Mare named only in 1976. One of the last of the lunar Mare to be named, so-called the Sea of Islands, because all of the mountain peaks protruding up above the Mare basalt look like islands in the sea. And just for artistic balance, we threw in Reinhold crater. Now, the straight wall. Like I said, one of the most beloved non-crater features on the moon. It's a scarp, but it's not a straight cliff like we thought back at the dawn of the space age. It's actually a fairly aggressive slope, maybe between 20 and 30-degree inclination. In actuality, a very spirited astronaut could probably descend it on foot, although mission control would frown on it. But located on western Mare Nubium, just south of our Zatchel crater, and nearest major landmark, Thabit crater. And the crater that the straight wall lies in has no name, but we can see it as this ancient crater creating this horseshoe bay, and then the western part of it is flooded by Nubian basalts. But we can still see evidence of the rim by the wrinkle ridges. So this entire huge buried crater, one of the largest on the near side of the moon, it has no name, so we unofficially call it ancient Thabit. And consider sunset on straight wall on the moon as the sunrise or sunset shadows advance across Mare Nubium. You're standing on the top of this 400 kilometer high precipice of straight wall looking across sunset on Nubium. On Earth, it takes almost exactly 2 minutes for the sun to disappear from the time that it touches the horizon to the time that it sinks out of sight completely. But the moon rotates much more slowly. Moon rotates, takes 28 days, 27 days to rotate. So sunset on the moon will take almost an hour. Now, wrapping up my program tonight, I'm going to talk about some nicknamed features on the moon. Now, just like deep sky objects have nicknames, like we don't refer to NGC 7000 as NGC 7000. No, we call it the North American Nebula. We don't call M8 just M8. It's the Lagoon Nebula. Well, features on the moon have a number of popular names as well. My lunar good luck charm, Meton crater. The combined forms of Meton C, D, and E craters makes a 4-leaf clover shape. My lunar good luck charm. The Alpine Valley, where it discharges into, or seemingly discharges into onto Mare Imbrium, this substantially wide channel narrows down to just several hundred yards wide between these two massive massifs right at the mouth of the Alpine Valley. And Chuck Wood calls these the Guardians. They kind of look like ancient Egyptian monuments to me. And I'd mentioned Thor's hammer, Mjolnir. So like I said, Agent Coulson can call off the search. We found it. Now, the Valentine Dome on western Mare Serenitatis, 35-kilometer wide, 300-meter high volcanic dome, unofficially known as the Linnaeus A1, but people call it the Valentine Dome. But why escapes me, because it does not look like a Valentine to me. It just looks like a plain old pancake. Cobra Head, the volcanic pit at the source of the lava flows that flowed down Schroeder's Valley. The heart of the moon. I mentioned why I named it that. Heart-shaped and very distinctly darker shaded. the volcanic ash blown out from Rima Hyginus. The lunar spider, the ghost crater Lamont, just north of the Apollo 11 landing site. The ghosts of Procellarum. I mentioned the lunar basins at one time had many craters on their floor before they were flooded with basalts. The southern Procellarum, no different. But today, some of the original flooded craters still are visible by the crowns of their rim protruding above the Mare basalt. And many of these are visible on southern Oceanus Procellarum, collectively called the ghosts of Procellarum. The railroad tracks, the strange parallel ray streaks extending northwest from Tycho crater. Crater rays traditionally converge at the center of the crater where the impact explosion created them. But curiously, the railroad tracks are almost tangent to the rim of Tycho. And the Golden Handle. The Jura Mountains form the outer rim of the sinus iridum on northwestern Mare Imbrium. But as sunrise is advancing in that region, it starts to illuminate the mountain rim prior to the interior of sinus iridum, and that creates the illusion of this handle floating against the darkness of space. And the Marias Hills, we call them the Marias Hills by nickname only. They have no official name. So everybody knows what the Marias Hills are, even though that's not an official name. The tadpole, of course, the very curious albedo feature Rainer Gamma. It is not an indentation or an elevation on the moon. It is simply a bright spot, an albedo feature with this curious tail. So it looks like a little frog tadpole. Oops. And the fireman's hat. It's upside down, but imagine the white elevated region, flip it right side up, and it looks like a fireman's hat, an inverted fireman's helmet, just to the northeast of Gassendi crater. And Huygens sword, and several other features. The stag's horn. This is back to our old favorite, the straight wall. But when you look at the straight wall itself, a feature the rim of a buried crater south of straight wall called a stag's horn, and then the hills at the very southern end of the straight wall itself. You can imagine that it looks like a sword. Straight wall is the sword itself. The little mountains are the guard for the handle guard of the sword, and the stag's horn is the handle. And collectively, we call this Huygens sword. And wrapping it up, I conclude by saying the moon is ever changing. The phases grow and shrink day by day. The shadows change hour by hour. The moon is a geologic wonderland, and the moon is accessible from your own backyard. Dark skies are not needed. The moon is the easiest thing to find in the sky. The moon laughs at light pollution. So there, it is. There's much to love on the moon, and I invite you to come join me on my playground. So thank you for your attention, and my voice made it.
Yeah, congratulations.
So anybody have any questions? I'd be happy to chat with you.
Thank you, Robert. And thank you for reminding me that you used to show up at AIC, because I think that's where we met. And you were graciously giving out thumb drives with many of your photographs on it. And I have treasured them and realize now where I ended up with them.
Yep. I was there representing the Celestron Telescope Company, and
that's right.
It was always great fun to be at AIC.
Yeah, I miss it. Also, somebody says hello. Mina Reyes sends her regards. She's a longtime member of EAS, and
wonderful. I've known her from the Texas Star Party.
That's right. That's right. Anyway, we're going to do questions here. They require a microphone. So I'm going to start with Bob.
Hello, Robert. Nice to meet you finally after communicating for years.
Very good.
I didn't have a question, just I was going to make an announcement that David forgot to turn the microphone over to me. Thank you. Yeah. Okay. On July 27th, the ALPO, the Association of Lunar and Planetary Observers, will have a conference. It'll be on Zoom, and I will be the keynote speaker that's on Saturday the 27th. So that's something that I just found about recently. And Robert, I write the book reviews for the Jalpo Journal. If you'll send me a copy of your book, I'll endeavor to get a review in the magazine.
Very good. Now the next,
I'm not sure whether you have my address or not, but I'll send it to you.
you bet. Now the next question is which book?
You have
Well,
one that you were just showing about the moon.
yes, that one is out. It was out last August. Another one by Firefly Books is coming out this fall, and I'm just finished a third observing companion book. Do not yet have a publisher for it, and I'm about 3/4 of the way through yet a fourth book about the moon. Again, no publisher for it, but one is in print available now through Amazon. The other one will be on the bookshelves in stores this fall. So
Okay. Well, send me the ones that are published.
I'll get one to you.
All right. Who else? Steve?
Robert, thank you for the very nice pictures. Right now, the big thing supposedly is water on the moon. And of course, we have the Artemis project that was going to look around the South Pole to see what's in those craters. But I have been told that there's actually water all over the surface of the moon, not in the form of a liquid or an ice, but in the form of molecular adhesion to the regolith particles. I'm wondering, what's the story on this? And is this water, how does it compare in comparison to what's supposedly at the South Pole?
Okay, the water in the for the sake of argument, let's say equatorial regions, is an interaction between the solar wind, which has a lot of hydrogen atoms in it, and the oxygen in the minerals in the minerals on the face of the moon. And yes, it is literally formed molecule by molecule. Now, over millions and billions of years, these molecules migrate. The solar wind plays on the face of the moon continuously. Coronal mass ejections can hit the moon pretty hard too. There is no atmosphere to slow it down. So these water molecules, one molecule at a time, can get pushed toward the polar regions. And over millions and billions of years, they finally migrate to where they fall into these cold traps, these permanently shadowed craters on the moon in the polar regions, where sunlight never reaches the bottom, even though the moon is a little further away from the sun than the Earth is. These regions on the moon are the coldest places in the solar system, colder even than the planet Pluto. So once that ice, that water molecule gets in there, it is frozen to near absolute zero. It does not sublime back into a gas like ice would if you pitched it out the airlock of the ISS. So given literally millions and billions of years of this process happening, eventually a significant amount of ice is going to accumulate. And that's the big holy grail, to prove that it really is there. Because without it, colonizing or establishing bases on the moon is going to be a lot harder. So it's something that quite a few unmanned missions are going to be looking at in the very near future. And I'm very proud that Southwest Research here in San Antonio, just on the other side of town from me, is at the forefront of a lot of that. And if you saw my article in the April issue of Astronomy Magazine, I wrote about the space research being done at Southwest Research. And speaking of Astronomy Magazine, the next issue will have my article about nickname features on the moon, many of which you just saw in this presentation. So keep an eye out for the next issue of astronomy as well. But yeah, that's the deal about the ice. It does form molecule by molecule by interaction with the solar wind, and given time, it finally accumulates in the cold traps at the poles.
All right.
Yes, I'm wondering why there are no volcanic peaks on the moon like there are on Earth.
The moon was much smaller. The degree of volcanism on the moon was more prolonged than fierce. The Maria are fairly thin for their size. They're more like a postage stamp stuck on a tennis ball as far as the thickness of the basalt on the moon, and it took almost 1 billion years for that amount of basalt to form, to accumulate. So volcanic eruptions on the moon are very slow. So the eruptions don't pile up Vesuvius-like volcanoes like they do here on Earth. The degree of heating within the moon, topic of debate. How much radioactive elements were there in the early moon? How much residual heat was there from the accretion stage of the lunar formation? So one thing that I never see anything spoken about is what about the early sun? Shortly after the moon was created, the sun was entirely different than it is now. As the sun went through the T-Tauri stage, where it had fierce magnetic fields and enormous solar winds compared to today, what effect did that have on the moon? What did magnetic induction do for heating both the moon and the inner planets? So the exact amount of available heat to create the volcanism is something that has not really been fully explained. But the lunar volcanism is definitely a long, slow, prolonged process rather than a violent, fast eruption that will build up a mountain. I lost you. You started to say something and then silence.
Test. All right.
There
We'll
you
try
are.
the other mic.
You're back.
Okay. Yeah. Nobody trusts me with anything technical, and with good reason. First thing is, Robert, I'd like to make a request again. I'd like you to put up your 3 books sequentially, slowly, so we can look at the covers of each. That's my first request. Can you do that again, please?
I don't have a slide that shows
No,
that.
no. You don't have to do a slide. You had them in your hands and you put them up, but you did it too fast from my point of view.
Oh, well, the one that you can get from Amazon, it's Exploring the Moon with Robert Reeves. My name is very pretentiously in the title to
Okay.
differentiate it from the other books out there called Exploring the Moon.
Okay.
And do a title search, and boom, there it shows up. The
And you had
paperback.
2 other books that I think you had on your desk there that I'd like you to hold up if you can. Forgive me if I'm being difficult.
No, well, the book that's coming out in, well, I was holding a magazine actually,
Okay.
from Southwest Research. I was going to reference something about lunar ice in it, but
Okay.
decided it would take too long. The book coming out from Firefly, I do not have a copy of it in
That's
a
okay.
physical copy. It is being printed in China as we speak, and then take a slow boat back across the Pacific.
And what is the title of it again?
A photographic lunar atlas.
Okay. I also wanted to say that I really enjoyed, I assume you took all those pictures yourself, did you not?
Yes, yes.
Yeah, I love looking at them. If anything, I wished you plot your duration on each of those images would have been slightly longer, because I was just sort of, just loving exploring and looking at those images. So
Well,
that was my
I
second
didn't want to go
comment.
long. I didn't want to go long.
No, we like long programs here. At least I do. The third question or comment is about the rays of the moon. You had mentioned that they're glassy and that they reflect back sort of like reflectors on signs. Is that because what happens is you have this massive impact It throws very hot material up into space. That the little it becomes droplets that are globular, and is it the internal reflections that cause the rays to look the way they do? Is that how that works?
Yes, yes. Some of the material, of course, is blasted out in rather big, lumpy blocks, and they crash back down, create secondary craters. But a lot of it is pulverized into virtually powder,
Mm.
and of course the heat melts a good deal. The impact of the impact of the impactor, the asteroid or the comet, converts all of the velocity, the kinetic energy into heat, and it vaporizes. Enormously hot temperatures, vaporizes the rock and splashes it out in this emulsified mist, which condenses down into glassy little particles. And those were brought back, many of them brought back on the Apollo missions. The famous orange soil, for instance, little glassy beads. And the curious thing about these, the little glass beads, I mean, they're sub-millimeter in size. I mean, fractions of a millimeter. You can put them under a microscope, and you can see craters on these tiny little beads.
Oh, that's wonderful.
So the cratering process goes further and further and further down to the microscopic size.
I'm almost done. I have just one more quick comment. I squeezed 4 questions and comments into this. Finally, I wanted to correct your pronunciation of PICO. It's Piku. It's
Oh.
named after the volcanic island in the Azores. And whenever I meet anybody from the Azores, I always tell them that there's a mountain named after their island that they're from or close to, that they can see up on the moon. I tell them where to look for it. And by the way, I think Pico itself had a last volcanic eruption in 1957, and I'm done with that. There you go.
Well,
Didn't
I
they ban
always-
you from that island? Yeah, yeah. Hold on.
Well, I learned something new with every presentation. Pico, I've always heard it Pico. Of course, everybody reads it and then mispronounces it because they've never spoken to somebody, a native, that knows the original. So that's very interesting. Thank you.
Okay. One of the things, Robert, is Bob Garfinkel again.
Eddie.
Is all your writing and your article is all very impressive, but I think a lot of the people here are unaware of your lecture tour in China a few years ago. If you could remark about that.
Well, yeah, we were mentioning AIC a while ago that held over in San Jose for a good number of years until this last one was the final one, the 2017 AIC. I was one of the speakers there, and the whole thing was wrapping up. Everybody's saying their goodbyes. We were passing out door prizes, and surprise, I won a Coronado PST. Solar telescope. And I've got this thing in my hands, and how am I going to get this on the airplane and take it back home with me? So I'm looking around, trying to find somebody I know, a local, that I could give it to, and they can mail it to me. And this fellow taps me on the shoulder, and I turn around, and it's this. Well, I call him short. He's a little shorter than I am. I'm not particularly a tall person. Chinese fellow, and he very politely asked me if I would consider coming to China to speak to the Chinese astronomy community about the moon. And I thought about it about 3 milliseconds. I said, hell yeah. Well, got the details from him, and his name was Tommy Tse. He owns 400 jewelry stores in China. The fellow is literally a billionaire, but he's also an avid amateur astronomer, very dedicated amateur astronomer. And as part of his jewelry empire, he has the TSL Foundation. That's the name of his jewelry company, TSL Jewelry. The TSL Foundation that brings, or did bring pre-COVID, twice a year, brings speakers from the United States over to China to talk primarily about astrophotography, because Tommy was a very avid astrophotographer. And I guess he liked what he saw at AIC, because he chose me. And we talked about it, and I got more details about it. And this is, well, this is something, I just can't pass this up. They brought both me and my wife over to China. It was supposed to be a 3-week tour, but Mary's work schedule is such that she can skip 2 weeks and cycle everybody over. But if she goes 3 weeks, it torpedoes her schedule to pieces. So we had to cut it back to a 2-week tour. But first class all the way over, the best hotels, chauffeured everywhere, translators everywhere. I mean, we were treated like royalty. It was astonishing. And turned out we actually were staying in the same hotel the president of China stays in. We got there and they said, "Well, you've had a room upgrade," and I said, "Okay." Got the pass for it and went up to look for the room, and we couldn't find our room. We were looking for a regular door, a single door. Oh no, it turned out to be this one with these big, massive double doors. When I passed it by at first, I thought it was a utility area, like maybe there's air conditioning stuff in there. No, that was the entrance to this massive 7-room, 2-bathroom, full kitchen suite that had a picture window on the 17th floor. Must have been 20 feet wide, overlooking Victoria Harbor. And I have never seen anything like it before in my life. And it was astonishing. I spoke to the Chinese Academy of Sciences in Beijing. I spoke to the Harbin Institute of Technology in Guangzhou, I think is where it was. To the Hong Kong Space Museum, to the Macau Space Museum, and oh gosh, I forget wherever else it was. It's coming up on 11 o'clock here, so names are vanishing out of my mind quickly. But it was an astonishing trip. I mean, like nothing I've ever had before in my life. So I'm very grateful, and I just don't know what to say about how lucky I was for that.
Well, that sounds great. I think I'll try to convince the EAS board to send me to that hotel. What do you think, guys? All right, a couple more questions here. First of all, a comment from Sebastian, who's sending hello from Alameda and a thank you for doing a presentation
My pleasure.
at the Montessori school there a few years ago. Nice of you to do that. And we have a question from Chris. Hi, Chris. Richard here. How do you know when it is sunrise and sunset on the moon?
In reference to if you're standing on the moon or if you're looking at the moon from the Earth?
Well, that's the question, I guess.
Well, if you're standing on the moon, it's sunrise because you can see the sun, of course, just like on Earth. There's no difference between sunrise on the moon and sunrise on the Earth, except there's no atmosphere on the moon, so the sun isn't going to be dulled or reddened or yellow or obliterated by clouds. It pops up above the horizon and it fries your eyeballs if you don't have any protection. Sunrise on the moon, you're looking at a particular area of the moon, the sunrise terminator, the shadow line between the sunlit and the dark side of the moon, slowly creeping across the face of the moon, moving at about a speed of a fast walking pace. Takes 2 weeks for the sunrise shadow to go from new moon all the way to full moon. So any particular area that's illuminated, well, the sun is above the horizon by definition.
Okay, well, thank you for that. Who else?
Should I stand up? I guess I'm standing up. It's okay.
Well, I can see you now that you're standing.
Oh, thank you. Thank you, Robert. Wonderful, wonderful. We've never met, but your talk is great. And your experience is vast. So I have heard that given the size of the moon is rather light for its size. Does that mean that the moon has caverns?
No, not necessarily.
Porosity on the moon?
The Earth has a density, average density, a planet-wide density of about 5.5 times water, and that includes this heavy iron core. The moon does not have an iron core like the Earth does. If it has an iron core, it's a very small one, and the average density of the moon is 3.3, 3.5, something like that, times water. about average density of the rock in Earth's mantle. So the moon is not lightweight by any means, but it is also not burdened by a heavy iron core like the Earth is. So there's nothing unusual about the moon's weight. It is a rocky body, and its average density is about the same as the rock in Earth's mantle.
Robert, I'll stand up so maybe you can see me.
Yep, you
discussion-
pop up above the heads.
Your discussion on the rays, I found from the craters, I found that to be very interesting. And I started to be thinking, why is it that the ejecta comes out in radial rays rather than circumferential circles?
You know, I don't have an answer to that. I wish I did. Um, Nobody's ever asked me that, and I've never considered it. Yeah, why do we have splashes of rays like the railroad tracks? Or, well, I can tell you why in the case of Kepler crater, why there are spokes going to the west, whereas there's just a homogeneous fan going to the east. And you look very closely at Kepler, or in the territory around Kepler, you'll see a number of mountain ridges, and the crater rays that washed out from from Tycho. No, I'll get the crater right, from Kepler. Preferentially passed between these mountains, whereas the mountains acted like a dam and created a blank spot between the spokes. In the case of Kepler, the rays were spokes were formed by the flow of ray material between the mountains. And you go over to the other side of Kepler, and the eastern side of it, we don't have a mountain system like that, or a series of hills that acted like a dam and blocked the outward flow. So east of Kepler, you have this homogeneous semicircular fan of rays, but you go west of Kepler and you distinctly have these fingers of rays, and they are projecting through the gaps in the mountains.
Hi, thanks for the great talk so far. I read a while back, I think Rachel Carson wrote that the moon was theorized to have been stripped off from roughly where the Pacific is. Can you speak to that? Do you know if that's true or?
No, a number of well-regarded scientists back in the late 1800s, early 20th century, had the idea that the Pacific Ocean was a scar left by the moon ripping off from the Earth. But the fission theory is what that is, the fission of the Earth splitting in two. That has been effectively disproven mathematically and by various other reasons, pretty much discredited. It's one of the lunar formation theories that is no longer looked on as being a possibility.
Okay, so is the idea that the mass of the moon is from the Earth's surface or partially from the meteor that impacted to create that explosion? Or
the moon is a combination, but primarily debris left over from Thea's impact. The Earth was severely, the proto-Earth was severely shattered. Theia was destroyed, and this molten emulsified mix of molten material showered out and coalesced back into the Earth, coalesced into kind of like a Saturn-like ring around the Earth, and the Earth, the moon coalesced out of that. But the moon is thought to be primarily left over from Theia, whereas our Earth is retained a lot of the heavy iron and heavy elements. Therefore, we have a heavy iron core. The moon does not.
All right. I think think we're going to let you get some sleep.
Well, it's been a long day. I've been working outside doing a lot of carpentry and got up to about 100 degrees today. So yeah, I'm kind of
Are you
kinda
able to take
feeling
one
it.
more? You want to take
Sure,
one more?
sure,
Okay.
sure, no problem. I'm just making an excuse for why I'm going to be babbling in a little while. Go ahead.
Thank you. It was wonderful to get to know our close neighbor, um, so much more intimately. And what is your what are your thoughts about why, as a culture, we don't study our close neighbor? I mean, in school, we just studied the planets. The moon was never even mentioned. And are there other cultures that that do study the moon and have more interest in our close neighbor?
Well, as a good American culture, the interest of the moon has been cyclic. The space race, of course, was a very big driver. The race with the Russians to get to the moon first. That was a political competition. Science rode on the coattails of Apollo. Apollo was primarily a political mission, and it's taken 50 years to get back to where we will be soon returning to the moon. So the, going to the moon, studying the moon, sending spacecraft to the moon is very expensive. It can't be done without massive governmental funds. And projects like that are at the whim of politicians that sometimes are not very forward thinking. So I'm not going to get into a political discussion about those kind of things because everybody has their opinion about the viability of this candidate or that candidate. But it is very true that some see more value in advancing science and going to the moon and enjoying the fruits of the technology we gained from doing that. Some see more benefit in that than others. So it's always been very cyclical, and I found it very amusing in some sense that the original push to get Apollo to the moon began after the failure of the Bay of Pigs invasion in Cuba. The American government was embarrassed and wanted to come up with something to show the world that, yes, we were a great nation. We could do great things. Therefore, Kennedy on the exactly on this date, back in 1961, is we choose to go to the moon because it is not because it is easy, because it is hard. But that was a political decision. Now, fast forward to the George Bush era, and George gets himself into a crack with various things around the world. Next thing you know, he's saying, we're going back to the moon. We're going to do this great thing, go back to the moon. Well, that faded away in no time at all. And then again, the next Bush Jr., we're going to go to the moon. When things get tough for him and he wants a distraction to make it look like we're doing great things. And again, no funding. That just faded away. It was a lot of talk. And then now we're finally piece by piece by piece getting to where after half a century we're going to go back to the moon. Now, what if what if something similar had happened when Columbus sailed and discovered the New World, the east of the Indies, down the Caribbean? What if as soon as he came back from his voyages to the New World, what if the kings and queens of Europe collectively decided to destroy the blueprints for all the ships and burn the shipyards and never sail the ocean again? That's essentially what we did after Apollo. We shut down the Apollo, the Saturn V assembly line, all the existing ones that were ready to go to the moon. Apollo 18, 19, and 20 already built, crews trained, ready to go, canceled. So we've been in this situation before. I very cautiously watch the Artemis program, waiting for the shoe to drop because it's happened before. So like I said, it's very cyclical, it's very political, it's very expensive. Therefore, governments have to be involved. And fortunately, now other countries have evolved technologically where they can participate in this. India, for instance, half a century ago, we would never dream India would be going to the moon. China, very viable space program. The Japanese, a very viable space program. The Russians, who initiated the whole thing with their missile program back in the 1960s, early 50s, they've pretty much faded out of the situation because of economics. They can barely keep their country afloat and fight a war at the same time. So I could go on about the politics of this all night long because I did write a book about it once, the superpower space race. But I did not want to drag this along too long. But it is a very cyclical thing. Every culture has its lore and literature and poetry about the moon. The American culture, the same. Much almost all cultures in the world have fables and stories about the moon. But the scientific aspect of going to the moon, we're not alone on that anymore. There are other countries now who are capable of doing it if they have the political will and are willing to pay for it. It's not just NASA anymore. So we will go back to the moon. And hopefully the powers that be will realize, there's much good in this, and we should put our heads together instead of bankrupting ourselves trying to do it. So we'll see what happens. We'll see if the greater good prevails.
Thank you. Wonderful.
You're welcome.
All right, Robert, thank you so much. And thanks to all who attended.
Yeah, my pleasure. It was a lot of fun.
Okay, stay well and stay in touch. I'm going to end the Zoom meeting.
Alrighty. It's been fun. Talk to you all later.